Hello everyone, good morning. Myself Subhendu Sukumar Nanda. Today I am going to present you with the topic of AJAX and OLAP. So AJAX, what is AJAX? AJAX stands for Asynchronous JavaScript and XML. In a nutshell, it is the use of the XML HTTP request object to communicate with servers. It can send and receive information in various formats, including JSON, XML, HTML, and text files. So basically why AJAX is used. So AJAX is a technique for creating fast and dynamic web pages. AJAX allows web pages to update asynchronously by exchanging small amounts of data with the server behind the scenes. This means that it's possible to update parts of a web page without reloading the whole page. So the next slide, what AJAX should be used for. So AJAX should be used anywhere in a web application where small amounts of information could be saved or retrieved from the server without posting back the entire pages. A good example of this is data validation or save actions. So now here you can see basically a web diagram where the AJAX process is explained. So let me go to the next slide. So for example, this is a prototype coding of AJAX where we can see how this AJAX process and the coding is done. So basically the decode doc type HTML and then the HTML, then the body and then HTML, XML request and the whole prototype coding we can see over here. So next, now going to OLAP. OLAP stands for Online Analytical Processing Server. It is a software technology that allows user to analyze information from multiple database systems at the same time. It is based on multidimensional data model and allows the user to query on multidimensional data. So here is a graphical representation of OLAP. Basically, this is a data warehouse component, and the data source, starting from the source to the data storage, OLAP engine, and footprint tools. So here, this graphical representation explains how this data warehousing is done. So OLAP basically uses this cube structure to store the data. Since OLAP contains multidimensional data, OLAP cubes should be used for that purpose. So if it is not a two-way data, then we can use some other format. But as it is a multi-dimensional data with various dimensions and various data warehouses, we have to use this cubical structure. These are the structures in a way that allows for storing data types from the heterogeneous source and analyzing it in a logical and orderly manner. So here is again the OLAP cube graphical representation, which explains how the data is stored within the OLAP cube. So now let's understand how this OLAP system works. So to facilitate this kind of analysis, data is collected from multiple data sources and stored in data warehouses that cleansed and organized into data cubes. So each OLAP cube contains data categorized by dimensions, such as the customer, geographic sales reason, and time period, derived by dimensional tables in data warehouses. Dimensions are then populated by members such as customer names, countries, months, or some other aspects that are organized hierarchically. OLAP cubes are often pre-summarized across dimensions to drastically improve query time over relation database. Analysts can then perform five types of OLAP analytical operations against these multi-dimensional database. So these are basically those five types of databases or the operations that are used in OLAP, starting from roll-up, drill down, and pivot, and all these. So let's go one by one. So roll-up, this also known as consolidation or drill up. This operation summarizes the data along the dimension. Drill down. This allows analysts to navigate deeper among the dimensions of data, for example, drilling down from the time period to years and months to chat sales for a product. Slice. This enables the analyst to take one level of information for display such as sales in 2017. So this slice thing, this allows we can take an example as a sales in 2017 or some other categorization of the data which slice displays. So again, the other form of data is which allows the analyst to select data from multi-dimensional or multiple dimensions to analyze, such as uh, sales of blue color balls in 2017. Okay, so the next categorization is pivot. Analyst can gain a new view of data by rotating the data axis of the cube. So pivot is a multi-dimensional chat where these cubes can be tweaked and we can get the data from this. So this slide basically explains the whole OLAP process, how this OLAP process is carried out. So here in the left, we can see the data sources. So from the different data sources, the data transfers and gets stored in a single data warehouse. From that data warehouse, it goes into the OLAP cube, which is a cubical structure of storing the data. And from the data cube, again, it gets segregated to the different users, and they use this data that is being extracted from the OLAP queue. So this is the whole process of OLAP synchronizations. So now let's go with the segregation example of OLAP. So OLAP system typically fall into three types. This is multi-dimensional OLAP, relational OLAP, and hybrid OLAP. So what is multi-dimensional OLAP? Multi-dimensional OLAP is that indexes directly into a multi-dimensional database. So what is next? Relational OLAP. Relational OLAP is the OLAP that performs dynamic multi-dimensional analysis of data stored in a relational database. Now let's next go to the hybrid OLAP. It is a combination of relational OLAP and multidimensional OLAP. Hybrid is the formation of a combined data that is of a greater or higher capacity. Okay, to process the superior data, and that is called MOLAP. So that is multidimensional OLAP, but this basically includes relational aspects of the OLAP data as well. So for example, now let's go to the examples. Now for examples, in the healthcare sector, a data warehouse can be used for predicting health risks and outcomes, generating reports and sharing data with insurance companies, and so on. If we go to the insurance sector, the data warehouse can be used to analyze customer trends and data patterns, irrespective of the consecutive years and from the yesteryears, and it can also help us in analyzing the data from the future years. In retail section also this can be used. It can be utilized to track items and customers buying patterns as well as determining dynamic pricing. Also this can include the various forms of demands that is in the retail sections from the customers. Yeah, so that's all for the OLAP and AJAX system. Thank you.